Welcome, everyone. Thank you for coming. I'm Marcia Minke with SunWize Technologies, and today's webinar presentation is Choosing the Right Charge Controller for Off-Grid Solar Systems. We're pleased today to have two presenters, Bruce Wilson from SunWize and Brad Barold from Morningstar Corporation. Bruce is one of our senior sales executives in our industrial power group. He's been in the solar electric industry since 1981. He's a specialist in off-grid power solutions and has been with SunWize for more than 13 years. He's sold Morningstar products since their beginning, and he sold over 3 megawatts of PV systems into the market. His hobbies are wine and good food. Brad Barold with Morningstar is a senior sales engineer. He has over 11 years of technical sales experience in the PV and semiconductor industries at Morningstar Corporation. He's instrumental in the growth of Morningstar's international business and product portfolio, specifically for the renewable solar energy market. His expertise is in developing global accounts, technical marketing and training, IT and networking, database management, and product development. Brad enjoys traveling as an avid outdoorsman. SunWize uses Morningstar almost exclusively in our power-ready and power station solutions. We have found them to be the most reliable controller on the market and excellent to work with. They share our customer-centric core value. The Morningstar product line can be trusted in the applications they are needed for, and they're a world leader in solar electric charge controllers and inverters, and in setting new standards in performance, innovative features, and quality and reliability. Take it away, Bruce.
Thank you very much, Marcia. I appreciate that. Brad, I know when my picture was taken, it was about 15 degrees out here. It was a roadside up in New Jersey, and we're evaluating some sites and doing some adjustments on some systems. So, you know, that's why I'm dressed up like that. Your comment you're over here, you're like 7 foot tall. Is that true? I mean, wow.
Yeah, I know. I'm definitely pretty tall there compared to the local populace. That photo was actually taken. We were on a mountaintop cellular repeater site, or what's called the BTS, and that's both my customers there as well as some of the local villagers that came up to see what all the fuss was about. So yeah, I definitely tower over them there.
You could play center on the local basketball team.
Yeah, definitely.
Well, Brad, let's get into the purpose here, why we're here. Let's talk about some Morningstar charge controllers and SunWize, and how to best look at what's out there today in the charge controller marketplace. I've been doing this for a long time. I've been doing this for about 31 years now, and since the beginning, we have always put charge controllers into a solar solution. Why do we do this? Why don't we just run the solar panel directly to the battery and let it rip?
Okay, well, the main functionality of the charge controller is it's really the heart of the system. So it's going to interface with not only the PV modules, but a lot of other power systems in the off-grid solution or the remote power solution. Okay, so the first and most important thing that the charge controller does is it's preventing the solar modules from overcharging the battery. If they were just connected directly, they would just provide unlimited power, I'm sorry, not unlimited, but unregulated power into the batteries, and the controller will prevent the battery from being overcharged. It's also going to put the voltage and current from the modules through several different types of charging stages. Okay, so it's going to optimize what voltage is applied, how much current is used, and manage several different charging phases of energy into the battery. This could be anywhere from 2, 3, or even 4 stages of charging. And then the other key function is load management. So just as we prevent the battery from being overcharged by the PV module, we also have to make sure that the battery doesn't get discharged so far that it actually is damaged, because extreme discharge of a battery can actually have an impact on the plates inside of it. So we do that with load management, or low voltage disconnect. So this LVD, that will prevent low voltage damage to the battery and disconnect the loads until the battery is able to recharge to a healthier state. And along with the charging and load control functions, there's just a lot of other information, system status. There's metering that can be shown with all the LCD and LED displays. In some cases, some of the controllers are sophisticated enough to actually provide remote communications. Okay, so there's quite a bit of info, and that's definitely all integrated together, as you can see in this diagram. The controller is sort of the in and out of almost everything that's going on in the off-grid system. Okay, and here's an example of the actual battery charging stages that the controller takes the battery through.
Okay. Well, now we know why we've done it for so many years. Now, I said I've been doing this a long time, and in the beginning, we had a basic shunt type charge controller. As the systems got a little bit larger, we went to multiple stage charge controllers, and then there was PWM, pulse width modulation. Now there's maximum power point tracking, or MPPT. Brad, could you give us a quick overview on each of these?
Yeah, definitely. As the controllers have changed through the years, they've been able to utilize different ways of controlling energy into the battery, some better than others, and of course they've evolved quite a bit. Morningstar's been on the forefront of that. As I mentioned, these battery charging stages, we have to take the battery through these phases, but in the beginning, it wasn't nearly as elaborate. The shunt controllers, this would probably be in the late 80s, early 90s when they were originating, had a very basic way of stopping power from coming from the PV and going into the battery. And that was to short circuit the PV module through the controller. Okay, that's the reason shunt is used. It's actually a bypass. Instead of allowing the current to flow into the battery, it's sent through the shunt control circuit. And this is essentially, there's not really any kind of control here. You're either charging or you're not charging. It's either on or off. So it's not very sophisticated, and it actually allowed a lot of heating to take place of the controller as well as the module, because the current was still flowing 100%. It just wasn't going into the battery. It was going somewhere else. Okay, so Morningstar actually utilizes circuitry that is a series circuit. It's a little more complicated in its design, but it actually has a lot of benefits in the system, and is far more scalable for larger capacities. What we do is, instead of shorting the module, we actually disconnect it completely. So our circuitry is in series, hence the name, with the PV module, and we actually can completely disconnect it from the battery. So the battery is no longer charged, and the module goes to a high voltage open circuit state. The VOC of the module is just kind of a rest state that it can go into, and there's no charging taking place. Then on top of that, we also apply our PWM algorithm to the circuit as well, and that gives us the ability to not only interrupt that circuitry, but we can control from 0 to 100% all of the current going into the battery. So if we want to send 0, 50%, 75%, 100%, we have total control over that current by using pulse width modulation. Okay, and that basically rapidly turns the circuitry on and off. Again, something really best utilized with a series circuit. Okay, so series PWM is what we use in the majority of our line, and then the most recent and beneficial technology utilizes some of the functions of PWM, but takes it even a step further, and that's maximum power point tracking. Now in this case, the front end of the controller actually contains an additional sophisticated element called a buck DC to DC converter that allows us to allow the modules to operate at their peak operating efficiency, which is going to be at the VMP, the voltage max power. And now the controller can also account for power fluctuations in the array. We can change with daily temperature and light level changes. And most beneficial is we can utilize a lot of the modules that are much higher in voltage that weren't designed for charging batteries, essentially. And these are the grid tie modules, higher numbers of cells, and the MPPT controllers can take those and really utilize them effectively. You can see here in the IV curve that as temperatures decrease, voltage actually increases because colder modules operate more efficiently, and the maximum power point tracker can take advantage of that extra gain in voltage. Because it's amps that charge the battery, not volts, we have to convert those into amps first, and that's what the maximum power point tracker does. So there's kind of a brief comparison, PWM versus MPPT. PWM being a little simpler and more limited in design, but is still highly utilized because of the variety of modules that are available, generally from 150 watts or less. And then with MPPT control, you can use those modules as well as some of the higher voltages as well.
Thank you. I appreciate that. That was a good overview.
Mm-hmm.
Now, I think that I'm pretty positive in this next statement that Morningstar offers the largest selection of charge controllers in the marketplace today. There's at least 6 or 7 different product names with SunGuard and SunSaver, SunKeeper, Sunlight. See a pattern there. We've got ProStar and the TriStar, both regular and MPPT. Could you give us a little bit of information on each of those, so again we're selecting the right charge controller for the job?
Sure. Well, this diagram here gives a good overview of our product families, and these are the different types of applications. Of course, none of our products are limited to these uses. This just gives an idea of, based on their functionality and their capacity, the types of uses that we can put them through. And then we've got the different categories here. First, let me talk about the maximum power point trackers. Those listed on the left, such as the TriStar and the SunSaver MPPT, those are available in, of course, the MPPT circuitry is built into those. The TriStar comes in a 45 or 60 amp capacity, and that operates at 12, 24, or 48 volts. And it's also got an optional meter display. And it can take any voltages up to 150 volts and convert those down to any of those battery voltages. So it's really quite the flexible product. Now the SunSaver MPPT, a little bit smaller capacity, still a maximum power point tracker, rated for 15 amps maximum, and that'll work on a 12 or 24 volt battery. And it can take up to a 75 volt open circuit module and charge either of those batteries. So again, quite flexible, just a little bit smaller in capacity. And it features, while the TriStar MPPT is a charger only, the SunSaver MPPT has the load control function built in at the same time, so both modes are there. Then moving on to the PWM line, these products are the pulse width modulation series circuit, so they would utilize modules that are of similar equivalent voltage, and this makes up by far the broadest range of our product line, and also the highest volume. So there's the TriStar PWM, similar in capacity, 45 and 60 amps, 12, 24, or 48 volts. But unlike the MPPT, it's just a series PWM circuit. And this control can be used not only as a charger, but also the unit itself is switched into a load control mode as well. So if you want both functions, you would actually use 2 of the controllers, one in charge mode, one in load control mode. It also can work with wind or hydro systems for diversion, and hence the name TriStar. It's 3 modes: charging, load control, and diversion. Now moving down to the ProStar, that's sort of the flagship product in the middle of the range and covers the broadest range in terms of applications and also power. We have both a 15 and 30 amp unit, dual voltage, 12 or 24. We've got an optional meter display on there. And we also have a specific 48 volt version of the ProStar 2 that's separate from the others. Now the SunSaver is a smaller product, 6 to 20 amps. Okay, so we have a 6, 10, or 20 amp version, and those come in either 12 or 24 volts. So they're specified for the voltage you want to use when ordered. Okay, and those are that is by far our highest volume product across any of our models, and used in a lot of both industrial as well as mobile systems, pretty much any use. Many of the customers I talked to, their first product ever they've used in solar off-grid was often a SunSaver, so it's a little famous in a way. The Sunlight is, yeah, exactly. You probably have a similar story. So the Sunlight is a variation of the SunSaver, but it's specifically designed for lighting applications. So it has the ability to turn a light load on automatically at nighttime. Okay, and that's a 10 or 20 amps, 12 or 24 volts. So we have those 4 versions. And that timer, it's got a little setting on the front. You can set it for different numbers of hours after nightfall. You can do dusk till dawn. Lots of functions there. Now the Sunkeeper and SunGuard, these are our little guys. They are chargers only, so no load control, but they are extremely compact and really optimized for single module systems. And the reason they don't have the load control is they're often designed around systems that have such a long standby time that they usually don't really discharge the battery much. The battery's sort of kept 80% or higher state of charge. So the Sunkeeper, we have a 6 or 12 amp, at 12 volt only, and it's actually able to mount inside of the junction box on the back of some of the PV modules. So that gives it some mounting advantages. It's also waterproof when you mount it in that way. And then the SunGuard, just a simple little 4.5 amp charger, 12 volts only. Just a favorite of OEMs or anyone that wants to find a quick and easy way to put a solar module and charger into maybe an existing design, such as a LED lighting system or even a parking meter type of application. Okay, so that's our smallest product. And then we also do have one product that's not a charge controller but is a inverter product, and that's the SureSine. It's a 300 watt pure sine wave. It's got a 200% surge, 12 volt input, and it's an inverter like many others in that small power range, but designed with a few more sophisticated features. You'll find it's got really good efficiency and allows you to provide a little bit of AC power in a remote site as well. Okay, so that's our product overview. Covers the majority of our families.
And I think one of the points you mentioned early in this is that with this chart, we're not limited here to a ProStar and a SunSaver being used in security. I know that I've done some situations where we've done TriStars in security applications, or even sunlight controllers, depending on what it is we're powering up at the time. So they're not limited to that. They're just a quick overview.
Yeah, just an indication of where many of them are used, but they're definitely varied in their applications.
Now, it looks like, we've mentioned MPPT, maximum power point tracking, several times, and that is the new hot topic in charge controllers. Exactly why have this industry made that step to MPPT?
Well, for a couple of reasons. I mean, one of them is just, as the power electronics technologies have advanced, you're able to provide a more sophisticated management of the power systems, get more energy and provide more flexibility. So, of course, it's kind of market customer demand based on the technology. But one of the main reasons that the MPPTs really had to come about is that the modules have changed significantly in the way they're designed. When just PWM controllers were out and modules were, a 36 cell type, lower power levels like that on the left in my graphic here, you can see that they were sort of inherently designed to charge 12 volt batteries. That was really the main use of solar. This industry's been around for a very long time, really since the 70s. So battery charging was the main use. Now, as the grid tie industry came about, where modules were interconnecting to the electric grid, that's done at a much higher voltage. So the modules have actually adapted to utilize more cells, much higher voltages. So the MPPT controllers were needed to allow you to convert those higher voltage modules down to lower voltages in order to charge batteries. Okay, so it really was based on a need for greater flexibility by the charge controller, and that's where MPPTs continue to help.
Sounds good. Sounds good. I know I put together, design solar systems every day, complete solutions. But a number of our guests out there also want to put together their own packages. And what kind of application-specific features do we need to keep in mind when we're choosing the charge controller for matching up? What kind of things do we need to be cautious of?
Okay, well, when you're making a choice with a charge controller, there's a lot of things to keep in mind. You know, when I showed the application use, there's specific features depending on the usage, you know, lighting and so on. But there's also a lot of decisions just on the features of the controller itself. So in the beginning, of course, I talked about shunt versus series. You know, a lot of the newer designs with PWM are going to utilize, of course, series. The switching, you know, on-off is kind of really not used much at all anymore, so you definitely want to stick with a more modern technology, PWM or MPPT. Environmental conditions, that's a big thing to be thinking about. You know, if this is going to be installed in a location that's extremely hot or cold, you know, you're going to need a product that's got a wide range of temperature, you know, so that it can handle that cycling. You know, off-grid or remote power is called that for a reason. You know, it's usually in very hard to get to locations, and that's because of extremes of temperature, altitude. So you definitely want a product that's mechanically going to be tough and can handle these extremes. Accurate and adjustable regulation set points. So there's a lot of different ways you're going to be charging the battery, different battery chemistries, lithium iron phosphate, lead acid, nickel cadmium, both sealed and flooded types. So depending on how you're utilizing those batteries and how you're charging them, you need a controller that can be adjustable. So you may need something as simple as a few different types to switch between, or something as sophisticated as complete programmability of the battery charging profile, which we offer on some products. So that's something to keep in mind.
And that would be something like the TriStar.
Yeah, the TriStar, exactly, completely programmable. It uses actually software that can allow you to go in and edit the settings very specifically. Like, for instance, nickel cadmium batteries, they have some kind of unique requirements, and we can definitely support those. So protections, that is an area where you know, as the products get more sophisticated, it doesn't mean that things aren't going to go wrong. We need to be able to protect not only from installer error, but as well as from things that may happen at the site. You know, short circuits, lightning, you know, that can occur in the area that can cause some voltage spikes in the ground. So we need to be able to protect from those things, and the controllers offer a level of protection from those, you know, instances. Communication protocols and interfaces. Some customers want to be able to get data from the controller, either a data logging file, or they want to communicate with it in real time. So we often have various types of data ports and industrial, you know, communications protocols that those customers can use to interface with the controller. Temperature compensation. This is offered on all of our products. Definitely something you want to look for. As the batteries are either warm or cool, their needs change in terms of the voltage that they should be charged at. You know, so you need a controller that's going to be able to account for those changes, and we do that with temperature sensors that are either built into the controller, or in some cases you can actually put a remote one right on the battery terminal itself. You know, so that's very important. Low voltage disconnect, as I talked about. If you have there's a risk that your load may discharge the battery too low, using an LVD is a good idea to keep that battery from being damaged. Battery PV and load status. You know, you need to know what's going on with the system. A lot of our equipment is operated in remote locations, and there's just really not a lot of human interface with them. They just kind of do their thing, and they do it well for perhaps years. But if you are living off-grid and you're living with the system and you get to know it very well, you know, you're going to count on the controller to tell you what's happening with the system. So we need to be able to show information, either simple LEDs or some sophisticated meter display that lets you know what you have to work with in terms of power. Self-consumption. You know, our controllers, we make the biggest effort to make sure that they consume as little power as possible, because if we're running on batteries, the more we use ourselves in the controller, the less you have to run your loads, which is the point of the system. So you want to make sure they are very efficient. The overall quality, we do a lot of mechanical improvements to the product to make them very rugged, seal them internally so that the circuits are protected from all sorts of you know, corrosion and other things in the environment that may affect them. And we also design them to keep them cool. So you'll see, you know, we have very robust mechanical designs large heat sinks to get the heat out. And then lastly, ease of use. Our products are designed to meet the needs of power users, like we talked about with the programmability and these telecom sites. But a lot of customers are, new to the industry, or they're RV owners, or they're living off grid, and they're not electrical engineers. They need to be able to just have a product that's simple to use. And a lot of our controllers can still be just taken out of the box and installed with very little configuration if need be. So we also think that's something to keep in mind as well. And with the manuals we provide, we give you both kind of a quick start as well as a more sophisticated setup if you'd like. Okay, so these are just many of the areas you kind of want to take into account when you're making a charge controller choice for your system, because it's not just about voltage and capacity. It's different degrees of features that may have a big impact on your system.
I know here at SunWize, when we design a system, that the self-consumption, the temperature compensation, the environmental conditions, all these things that you've listed here, they're all very important in what we put into one of our total packages. Temperature compensation, you can, if you're going to be in a cold climate area, you can definitely, in our sizing programs, you can definitely see that battery size overall capacity increase with the colder temperature. So you need to adjust your battery bank with that in mind. And the self-consumption, the charge controller does consume a little bit of power, so you've got to be aware of that as well. So
yeah,
all in all, great points, Brad. Very good points.
Great.
What types of mechanical and electrical technologies sets Morningstar apart from other folks that are out there in the controller industry?
Well, as I kind of alluded to in the past slide, that's something to take into account depending on where you're, putting these systems, is the mechanical design. It's not just a circuit board. With power electronics, the reason they're named is because it's not like a cell phone where we're kind of just showing data and information. The product's actually doing a lot of work. There's some serious current or wattage flowing through the electronics. So our biggest need to increase reliability is to get that heat out and allow the product to operate efficiently. The more efficiently we operate, again, the more power is going into the battery and the less it's being wasted in this conversion process. So this is all really important and has a big impact, over many years in terms of your total system cost. So one of the things you do is if you look at our products, you'll see that the design of each controller is pretty unique. We've really built each controller from the inside out and made sure that it's going to meet the market need, and then we finish it off with a very custom design. In this case, we're looking at a heatsink from our TriStar MPPT, and those are the power transistors there on the bottom. They're called MOSFETs, and that's where the heat's most of it is coming from. So that's where we've designed to get that heat out through all of these fins. Okay, so you'll see that we use these a better quality extruded aluminum heatsink here. When I say extruded, it's actually pushed out, sort of like pasta, in that it's a two-dimensional shape, and because of that, then it's actually very pure because we don't have to cast it. Okay, because pure aluminum does a better job. It's more conductive. Okay, so that heat sinking is something that is extremely important to its overall efficiency. And we actually don't use fans in our products because we think the fan is it's a bit of a failure point. You can always get more power out of a system by blowing air over it and using active cooling, but that fan fails and you needed it to maintain your controller, then you might be out of luck. So we really tried to avoid that at all costs. And one of the things is, as I mentioned, efficiency. Here's actually some graphs that show Morningstar's efficiency of one of our controllers on the left and then one of our competitors on the right. And this is our competitor's graph is sort of typical because that's how a lot of power electronics do behave, is they get about a third of the way up to their maximum power level and they hit their peak efficiency. So that's the best they'll do. But as they continue to use more and more energy, they will actually lose efficiency because they start to get pretty hot. And on the left, you can see that the Morningstar product, we actually have a very flat efficiency curve. And in this case, what we did to do that was we use what's called a multi-phase circuit design. Our 60 amp product is actually 3 20 amp controllers that are built into one product. Okay, so we have sort of a 3-speed transmission in a way. And that gives us the ability to change and use either 1, 2, or 3 of those circuits at the same time, depending on the amount of power being used. And you can see about a third of the way up the graph there, you see a little bump. That's where we shifted into the second power stage. And then again, at about 2,000 watts, we utilized the third. So these types of internal circuit designs give us the ability to give a much wider operating range at maximum efficiency. And that makes the product, more flexible, puts more power into your battery. Okay, so these are some of the things we're doing internally, and we use some type of circuit design like this or the mechanical design of the heatsink in all of our products so that they're all very robust. Okay.
Sounds good. There's been a significant effort by I know by SunWize and by Morningstar when it comes to the rating of charge controllers. We all want to make sure that they're approved. And Class 1 Div 2, which is for hazardous location, UL 1741, not all charge controllers have these ratings. Why have SunWize and why has Morningstar made this investment to get these ratings? What does this mean for charge controllers?
Well, the hazardous location is really critical. The oil and gas industry and even others that have to use that need power, in a dangerous location, such as this well where there's a gas line, they have to go through a very extensive set of tests that make sure that when the product is being utilized in a normal way, during its normal operation, that it's not going to do anything that's going to cause a source of ignition. Because if there's a gas leak at one of these sites, then you can have an explosion. Okay, so what we do is the product is actually designed with this in mind. We make sure not to utilize any relays that could cause arcing when they click open and closed. We make sure that the product doesn't get too hot so that there's nothing where it could actually start an explosion through intense heat, short circuits, things like that. So the product is designed from the ground up for this use in these industries, and then we actually put it through a certification from an independent lab. In this case, we work with ETL Intertech to make sure that it is actually verified to be Class 1 Division 2 compliant. And you can see that this is a very big industry. All these wells are all across the country as well as around the world. And in this case, the ISA certification and the CSA certification make sure that we're compliant for both the United States and Canada, and we have uses, as I said, around the world and other countries as well. And with the Class 1 Division 2 ratings, we actually have these on both the SunSaver product and on the SunKeeper product. So if you look on those, you'll see the code mentioned actually on the product itself, so that if it's inspected, it's verified to be usable in these markets.
Sounds good. I know that SunWize here at SunWize, we've just introduced a line of Class 1 Division 2 rated solar modules, and we have those available from 5 up to 150 watts, all with a nominal 12-volt battery charging in mind. And I know that that took us a while to get, and we had to jump through a lot of hoops to make that happen, but they are now rated, and like yours, ours has we're proudly labeled those right on the back of the module that they do meet those standards.
Yeah, we definitely view this as something that kind of sets us above the competition, because these certifications, you're right, they're not easy to get. It takes some time, and we actually have to be recertified. The product can't change, and it needs to be regularly inspected to make sure that it maintains this. But we're proud of that as well, because we know that the product can be utilized with confidence, and that when you look at these certifications, that we stand behind them. And there's other areas as well, such as the full UL listing even encompasses safety and voltages as well. So there's many different industries that rely on these certifications to make sure the product's going to be safe and reliable. So
very true, very true. Now, a little while ago in our conversations, you mentioned data logging and remote communications. Can you give us a little more detail on that? What kind of options are available to us?
Okay, well, a lot of our products, starting at kind of the mid-range in terms of power and then going up from there, offer different ports for getting information. Some of those, it could be a meter port to allow an optional meter to be added, or maybe even a remote meter, such as in the RV industry. They really appreciate those. But those ports can also be used to function as a serial port as well, meaning they can connect to a PC or other types of hardware, and you can actually get data out of the controller. Okay, and you get up into even more sophistication with some of our TriStar products. They have serial ports, what are commonly referred to as RS-232, RS-485, and even Ethernet, which is the same type of network port that's found on almost any laptop or desktop PC. So these products actually use what's called Modbus, which is a communications protocol that is an industry standard, so that it's available and it's clearly understood, and we actually publish the specification for the product so that any customer that wants to get data from our products isn't locked out. They know exactly what they're getting and how to get it, and we want to support them in that because it makes our products more widely used in all of these applications. So in this example here on this slide, you're actually looking at our MSView software. It's a PC program that we use, and you can actually access the data logging files inside of the controllers through these ports. And what that does is gives you the ability to look back in time, see how your system did, not just how much energy was generated, but a good idea of how well the battery is being used every day, because that's what's really going to make sure that your system is going to last a long time, the sort of cycling of that energy. And then in this example, our TriStar MPPT has built-in Ethernet, and you can actually connect to it using a web browser. It has a small web server that gives very, I guess, I'd say simple yet wide spanning data, in terms of all the way up to 90 days, 200 days of data logging that's occurred in and been stored in the internal memory of the controller. And with just a web browser, you can actually connect and view all this information at once. And you don't need any kind of software. We've even had customers use an iPhone to connect and see what's happening with the charge controller. So that level of sophistication is enhanced as you get into the higher end products like the TriStar and MPPT. Yeah, and overall, we just think that data is going to play more an important role in all of our products, because people want to know that the battery is going to last a long time, and there's a lot to be gleaned here by looking at this information.
Well, Brad, on this one you have the TriStar MPPT. On the previous slide there was the MS View. Are they available on, I assume this is just available on the TriStar? What's the MS View available through?
The TriStar is the only one that has Ethernet at this time, but MSView actually supports many of our products, pretty much any of them that have a serial or Ethernet-based communication port. So just off the top of my head, that would be the SunSaver MPPT, the SunSaver Duo, the SureSign, all of the TriStar family, both PWM as well as MPPT, and we're actually working quite hard to make sure that the majority of our products coming out from now on do have a way to be communicated with in one way or another. And you'll find with our products, often the ports are built into the controllers. There's a lot of web boxes and kind of external things you can buy at an extra cost that will enable that. But with ours, it's very often a standard feature, and that's just because we're involved so much in these industrial applications that SunWize and Morningstar serve so well. We think they're really important enough to be standard.
I know that more and more as solar becomes commonplace, I'm getting questions about data logging, and they want to see what's happening from somewhere other than being at the site. So I can see this being a big option in the future.
Yeah, that's the benefit of why we're moving towards Ethernet, is because it's a packet data protocol, which means it can be sent over not only Ethernet and network switches, but wireless connections, even satellite or cellular. So really there's not anywhere you can't get data if you invest in the right infrastructure. Mm-hmm.
Now, Brad, I got one final question for you. I want you to sit there at your desk and get out your crystal ball. And what's coming down the pike? What's in the future that you can tell us about? I don't want you to give up any company secrets or anything, or you have to be hunted down. But what do you see that you can tell us about?
Okay, well, one thing that we have coming that we're really excited about is our TriStar MPPT high voltage controller, and this is going to continue to expand on some of the technologies I've just been talking about with maximum power point tracking, but take it even further. And this product has a 600 volt open circuit maximum, so we can work with any voltage up to 600 volts. Generally, that's going to be, when you're charging a 48 volt battery bank, it's going to be between 200 and 500 volts DC. But the reason customers want to go even higher in voltage is you get much smaller wire gauge, you can run even greater distances, and also, as we've seen in the grid tie industry, those types of high voltage string configurations are really what those markets are used to working with. You know, being able to just click those MC connectors together one after the other and wire those array for a high voltage. So if we can provide a controller that can utilize those and still provide that down conversion to charge, in this case, a 48 volt battery, it really makes the systems quite flexible and powerful. So, and again, efficient, another large heat sink there, and a fanless design. So we're excited to be bringing the TriStar MPPT to the market to continue our offering in the MPPT realm. All right.
Sounds good. I look forward to being able to incorporate this into some SunWize power solutions down the road.
Great.
Now, Brad, that's all the questions I had today. I want to thank you for being a part of this. I think we did help maybe clarify a few things for some people out there. And thank you for taking the time with us.
Okay. Thank you very much, Bruce. I'm always happy to be here.
Great. Thank you, Bruce and Brad and everyone for participating. Excellent information on Morningstar charge controllers for off-grid solar systems. Please contact your sales executive and visit our SunWize website for more information. We welcome your feedback and questions. And we'll see you next time when we present on SunWize Power Systems. These systems are currently providing reliable power to thousands of industrial applications worldwide. Thank you, everyone. Have a great day.